Okay, so this is our aim number 10 notes. And this is going to be for the kinetic molecular theory of gases. This is going to help us to explain gas behavior. First thing we need to know are the 4 postulates of the kinetic molecular theory of gases, or the ideal gas laws. And the first of the postulates is that a gas is made of tiny particles. And these tiny particles are in constant, random, straight line motion. If you picture a racquetball court with a bunch of high bouncy balls throwing around in all different directions, that would be analogous to how gas molecules behave. The second postulate is that the gas molecule volume is so small that their volume is negligible. That means that their volume is so small compared to the space that they're in that we can disregard their individual volumes for the molecules. The third postulate states that gas particles collide with each other and with the walls of the container without losing any energy. They actually transfer the energy to each other. They change paths, they change direction when they bounce off of each other. And again, if you picture the high bouncy balls in the racquetball court, that will give you a good picture of what the molecules of gases, or how the molecules of gases behave. We call these elastic collisions. So that energy is transferred between the colliding particles. And the fourth one says that the gas particles don't attract each other. This is what allows them to move randomly, is because they don't attract each other. Now, real gases deviate from the KM2 rules. That means that they don't completely follow the kinetic molecular theory rules, mostly because ideal gases don't actually exist. It's just a set of parameters that help us explain how most gases behave. But the reason why they don't completely follow or deviate is because gas molecule volume does matter, and because gas molecules do actually attract each other. There is a certain small amount of intermolecular force of attraction, even in the gas state. Now, we can manipulate the conditions to make real gases behave more ideal, and real gases behave most ideal under conditions of high temperature and low pressure. This is when the gas molecules are furthest apart from each other. They spread out the most, allowing their volumes to be least important and allowing their attractions to be overcome the most. And I'd like for you to remember this by thinking about an ideal vacation situation where maybe you're sitting on the beach, basking in the sun, with no one bothering you. That's that low pressure situation, high temperature, sitting on the beach. High temperature and low pressure are when gases behave most ideal. Now, the gases that will behave most ideal are light, small gases. They're small volume, and their weak intermolecular forces of attraction cause them to deviate the least, which means that they follow the rules of the kinetic molecular theory the most. And that last letter there is, there we go, it's supposed to be an F. And finally, Avogadro's hypothesis states that equal volumes of gases, if you keep them at the same temperature and pressure, these containers will have the same number of molecules of gases. And for example, if you have a 1 liter sample of carbon dioxide and a 1 liter sample of hydrogen gas, and they both are held at the same temperature and pressure, let's say that they're both at 298 Kelvin and they're both at 1 atmosphere of pressure, and this is getting cut off for some reason, the pressure and the temperature. But if they're both held at the same temperature and the same pressure, they're going to have the same number of molecules in each of these 2 containers, and these boxes represent containers of molecules. So this is just a shorthand of the notes for kinetic molecular theory of gas. We will certainly go over this again in class, but this will fill in the notes for aim number 10 so we don't lose any time since I am at jury duty today. Please make sure that you put these in your notes as aim number 10. Leave this up on the board for as long as you need to for everybody to copy these 5 points from aim number 10. And if you need to replay it, you can certainly go back to my website. Everybody has the link on the Remind app. And tonight, when I find out whether or not I have jury duty tomorrow, I will send out another message to you to let you know where to find the information for tomorrow's class, just in case I'm going to be at jury duty again. All right, be good. Have a good day.